Hi everyone, Ewan here. Welcome to part 2 of solving forces in the plane, so 2D forces using algebra. So if you haven't seen part 1, I would recommend it because it was easier examples, and so today we're going over slightly more complex examples where the angle between F1 and F2 is not 90 degrees. So I have a few examples here today. First one here, as you can see, find the resultant force and its direction. So actually here, it's the horizontal direction. The vertical direction. Let's just write it here. Vertical direction. But anyway, as always, feel free to solve it by yourself. Pause the video and solve it by yourself. But I'll just go right ahead and do it now. So let's try and make a good graphic. So as always, we want to try and make some sort of triangle with all the angles. So here we have our 20 kilonewtons, just like so, and our 30 kilonewtons. So this is 20 and this is 30, and here we have our resultant force, more or less. Like this is not exact. And in terms of angles, so this is going to be our vertical axis. And then in terms of angles here, this is the most critical one between the two forces. Here we know from the drawing, the figure 3, that there's 60 degrees between the horizontal and this pillar here. So this is 60 degrees. So if we use the angles for rules and simple trigonometry, then this is 60 as well. And up here, this is where it gets a bit more complicated. Well, not really actually. Up here we can see that 20 kilonewton force here is 45 degrees from the horizontal. So this is basically the same, so 45 degrees here as well. 45 degrees, and so the angle here is 105 degrees. So far, so good. Now, this angle here between the vertical axis and the horizontal axis is 90 degrees because the axes are always perpendicular. And we also know that this one here is 60 degrees, meaning that this angle here is 30 degrees, the big one. And if we call this angle alpha, we'll use it for later. But this is for the second part of the question, for the angle between the vertical and our force. But anyway, let's start solving R. So if you remember the formula, R squared equals F1 squared plus F2 squared minus 2 times F1 F2 cosine, and then the angle between F1 and F2. Now, in the last episode, this was 90 degrees, so this would end up being 0 and we would cancel out the whole factor. But in this case, it's equal to 105 degrees because we're just adding the 60 and the 45. So if we just go ahead and solve this, R is equal to the square root of 20 squared plus 30 squared minus 2 times 30 times 20 cosine 105 degrees. There we go. And this is going to give us an answer of 40.13 kilonewtons. There we go, that's fantastic. And then for the second part of the question, the angle between the vertical and our resultant force. So we've decided that this small angle here, the direction, this small angle, we're going to call it alpha. And if you remember correctly, in all triangles, there's this sine rule. So the 20 divided, so the 20 from here divided by sine of the opposite angle. So this is where it gets quite tricky. We need to make sure we choose the right angle. So we know that this big thing here, this here is 30 degrees. This here is 30 degrees, and the small angle here is alpha. So the angle inside the triangle is 30 minus alpha. So let me just write this here. There we go. Is equal to the resultant force over this angle sine, and the angle opposite is 105, just like we've used before, between F1 and F2. And there's a third one, which would be 30 divided by this angle here, sorry, but we don't need it here because we have everything we need. And so we can calculate, we know everything, we know R, and we just need to find alpha. So 30 minus alpha is equal to sine inverse, because we have sine inverse. And then if we do like this, it's going to be this, if that makes sense. So that would be 20 multiplied by sine 105, sine 105 degrees over R, and R we just found earlier is 40.13. And this is going to give us an answer of, let me just pull out my calculator. So that would be sine minus 1, 20 times sine 105 over 40.13, which gives us 28.78. Fantastic. 28.78. And so this gives us a final answer for alpha of 28, which is 30 minus this answer here. So 30 minus 28.78, which gives us 1.22. 1.22 degrees. Final answer. Perfect. And you can see up with the answer up here. There we go. This is all correct. So if you have any questions, feel free to post them in the comments. I'll reply to them as best as I can. And if you find this video helpful so far, if you could just leave a like and subscribe, and maybe share it with your friends if you think it will benefit them. So anyway, let's go back to another question. This one is quite similar, but it's the F forces are a bit more, it's a bit harder to get that first triangle right. So let's start off with, this is going to be the 90 kilonewton force, and this is going to be the 70 kilonewton force. There we go, with a resultant. Fantastic. And then we have the same as before. So this, we know from this drawing here that the angle between our 90 kilonewton force and the vertical is 15 degrees. So we just have to do the same thing here. 15 degrees. And this one, so, and here we know that the angle between the 70 kilonewton and the horizontal is 55 degrees, and this is 90 degrees. So this means that this angle here is 45 degrees. And so that's the angle between the vertical and the 70. So this one here ends up being 45 degrees. 35 degrees, my goodness. 35 degrees. There we go. And that's the angle between the two forces, which is the one we need to calculate R. And we just add R here so it's a bit more comprehensible. There we go. So if we do the formula again, R equals that massive bracket of f1. So f1, there's no predetermined, so let's just say it's 90 plus 70 squared minus 2 times 70 times 90 times cosine, and then 35 plus 15 is 50. I'll just squeeze that in here. There we go. And that is going to give us the answer of 70 kilonewtons. Fantastic. And now we're going to get the answer. So this is, we want the answer for the horizontal. Again, it's not really written correctly in the question. We want the angle between the horizontal here, which is, we can call it alpha, and so this means that here is also alpha, and this angle here we do not, oh yes, it's 55 degrees. Right, so anyway, let me just write r over sine of, that would be 50 degrees, is equal to 90 over 55 degrees. Sorry, this is 55 degrees. So if you don't know why 55, because the 70 kilonewton force is 55 degrees away from the horizontal, so we just put it here, so 55 and alpha, and then the alpha here, the angle, the big angle in the triangle is just the sum of both of them, so that would be 55 plus alpha. Here we go, and we can do the last one again, which would be 70 over sine of this angle here, but we don't need it. That's perfect. So then we do it like, as always, 55 plus alpha equals sine inverse of 90 sine 50 degrees over r, and r we just found above, which is 70. Now this is going to give us 80 degrees, and finally alpha is simply equal to 80 minus 55, because we've just used it here, which is equal to 25 degrees. Final answer. There we go, and you can double check it's correct what's here. So there we go, 70 and 25 degrees, and voila. So this is all we have for today. As always, any questions, please put them in the comments, and thank you very much for watching. If this was helpful, please leave a like and subscribe, share with your friends, and if you have any other topics you would like to discuss, or you would like me to have a look at them and do some exercises together, then feel free as well to put them in the comments, and then I will have a look in my own time and make new videos. Thank you very much, and see you soon.